Okay, your lesson number is 27A2 for piecewise functions, page 42. 27A2 for piecewise functions, page 42. 27A2 piecewise functions, page 42. You're going to do three things in this section. We're going to evaluate, graph, and write. And for today, we're going to evaluate first. A piecewise function is just like what it sounds like. It's two or more pieces of different equations that are made up to make one function. And so when you see these functions, you're going to see two or three different equations, and they're going to have restrictions with them as well. So when you evaluate, the first thing you're going to do is you're going to look at the restriction. Then you're going to choose your equation. Then you're going to sub in. So you won't be subbing it into all of the equations. You're just going to sub it into the one that works with the restriction. Okay, so let's go over into our examples page. So your first piecewise function looks like this. F of x equals x plus 2 and 2x plus 1 when x plus 2 is x is less than 1, and when 2x plus 1's x is greater than or equal to 2. So we have f of x equals x plus 2 when x is less than 2, and 2x plus 1 when x is greater than or equal to 2. So for A, if they ask you for f of 0, you're going to look at the restriction first, and you're going to ask yourself, is 0 less than 2, or is 0 greater than or equal to 2? 0 is less than 2, so I'm going to use x plus 2. Now I'm going to sub it in. So f of 0 equals 0 plus 2, so f of 0 equals 2. I don't have to worry about the other equation because it didn't fit its restriction. Let's do another one. This time let's do f of 2. So again, look at your restriction first. Is 2 less than 2? No. Is 2 greater than or equal to 2? Yes. So I'm going to put it into the second equation, which is 2x plus 1. So f of 2 equals 2 times 2 plus 1, or f of 2 equals 5. That's evaluating. Okay, the second piece is a little more in depth. The second piece works with graphing. Okay, so the first thing you're going to do is you're going to graph one piece of the function. And these start out with f of x, so they'll either be in y equals mx plus b form or y equals a number. Okay, then you're going to graph and shade the restriction. Remember, the restriction is the inequality part. Then we're going to erase what doesn't exist, meaning we're going to have this long piece for our line, and we're going to have a shaded region. So we're going to erase the part of our piece that doesn't exist in that shaded line. Then we're going to repeat for each piece. Okay, so let's try this on our examples page. Okay, so your first example for graphing is f of x equals x plus 2 if x is less than 0, and x when x is greater than or equal to 0. Okay, now I'm going to have to use a pencil because we have to erase. So the first thing we're supposed to do is we're supposed to graph this line. F of x equals x plus 2 because we have two pieces here. All right, and this is in y equals mx plus b. So I'm going to begin at 2. And then my slope is 1, so I'm going to go up 1 over 1, up 1 over 1. And I'm going to draw a nice long line all the way across my coordinate plane. Now I'm going to look at the restriction, okay? And I'm going to use a color so we can see this a little bit better. So now it says I'm supposed to graph this restriction. If I was going to graph x equals a number, that's a vertical line. So here I am at 0, okay? And I'm going to graph a vertical line. And it says it's less than 0, so I'm going to shade to the left. Then it says erase what doesn't exist in your shaded region, because what's happening here is these are all your solutions. On this line, these are the ones that exist, okay? So I'm going to erase what doesn't exist. I'm going to erase this piece. And since it's a less than, I'm going to use an open dot. I'm just going to go back in and darken what actually exists, because the shaded region is not my answer. The line is my answer. The shaded region just got me my answer. Someday when you're more comfortable with this process, you don't have to do the shaded part. Oh, crud. It should have gone clear to 0. Dang it. I didn't see my own shaded region. Sorry. Okay, so my line goes clear to 0, open dot. Okay, now let's do our other piece. Our other piece is f of x equals x. That's still in y equals mx plus b. It just means that my b was 0. So I'm going to begin at 0. And then I'm going to move up 1 over 1, up 1 over 1 with a nice long line. Okay, now I'm going to draw in my restriction. I'm going to use another color because the orange was kind of hard to see. Okay, I have the same restriction as far as x equals 0. Okay, so I have a vertical line. And then it says it's greater than or equal to that. So that would be to the right. I'm going to shade to the right this time. So now it says erase what doesn't exist. Erase what's not in the green region. So it's everything on this side of my line. It's a closed dot because it was a equal to, and I'm keeping everything to the right. So my final answer is the orange and the green line. Okay, let's try another one. One half x plus 3 halves. X is greater than 1. And negative x plus 3 if x is less than or equal to 1. Okay, So start out with your pencil, and you're going to graph this first line, 1/2 x plus 3/2. So we're going to begin at 1.5, because that's what 3/2 is as a decimal. And then I'm going to go up 1 over 2. Now you're in the middle of a half space there, so make sure when you go up 1, you're still in a half space. Up 1 over 2, up 1 over 2. Nice long line. Now we're going to look at the restriction. X is greater than 1. So this is when I take my, and draw my vertical line at 1. And it says it's greater than 1, so I'm keeping to the right of this. And it wants an open dot since I don't have that equal to. So I'm going to erase this piece. And I'm going to darken the right side. Okay, now let's do the second one. F of x equals negative x plus 3. So I begin at 3. Then I'm going down 1 over 1. Down 1 over 1. I know I cut through a dot that I already used, but that's okay. Okay, now I'm going to draw my vertical line in. We have a vertical line at 1. Except this time it says it's less than or equal to 1, so I'm shading over here, which means I'm erasing the right-hand side. Notice how we share this point at 1, 2. And this is an equal to, so that means he gets to override that. He gets to fill that in and extend his line then to the left. So that one shared that point. Okay, let's do one more. Okay, the last one is an example of a step function. And step functions are going to look just like what it sounds like. They look like stair steps. So we have a function that looks like this. F of x equals 1, 2, 3, and 4. And then their restrictions are compound inequalities. So f of x is 1 when x is between 0 and 1. F of x is 2 when x is between 1 and 2. F of x is 3 when x is between 2 and 3. And f of x is 4 when x is between 3 and 4. Now, this is in all four of these are examples of y equals a number, because we have f of x, which is the same as y, equals a number. So that means all three of these are going to be horizontal lines. Remember, they're supposed to look like stair steps. So when we start out with our first one, we have f of x equals 1. So we have this long horizontal line. But let's think about this realistically. This line only exists between 0 and 1. So if I take my colored marker back in here, instead of having to do all this crazy shading, here's my horizontal line, but this line is only supposed to exist between 0, closed dot, and 1, open dot. Everything else doesn't exist. Okay, so the next one is f of x equals 2. So I have a horizontal line at 2. but this line only exists between 1 and 2. So I'm going to take my colored pen and I'm going to look at my horizontal line. Here's x is 1, closed dot. Here's x is 2, open dot. Everything between there is my graph. Everything else is gone. So then it gets to the point where you can just say, okay, I know I have a line at 3, but I'm only going to draw it between x is 2 and x is 3. Save yourself some time. So you know you have this long horizontal line at 3, but you know it only exists from 2, 3 to 3, 3. And you know you have a horizontal line at 4, but it only exists between 3, 4 and 4, 4. So here's my horizontal line and exists between 3, 4 and 4, 4. That's my step function. Now they don't always have to be that close together and they don't always have to be of equal length, but they will always look like steps. Okay, so that's where we're going to stop for today. You know how to evaluate and you know how to graph. I would encourage you to watch the video again and make sure you have all the notes down as I have them, and then you can practice problems.